3.6, multiplying matrices. Right here on the corner. This one? Yes. 3.6, multiplying matrices. Right? So, the most important thing, I'm going to write it in pink, I'm going to put a star by it. It is extremely important. In order to multiply matrices, the number of columns in the first must equal the number of rows in the second. Okay? In order to multiply matrices, the number of columns in the first must equal the number of rows in the second.
So it's kind of like a fraction where the denominator, when you're dividing it, you have the common denominator.
When you're adding and subtraction on, yes, fractions you do. Okay, so that's the most important thing. So every time someone tells you to multiply two matrices, that's the one thing that you have to check. Now, I'll show you. We're going to start off really easy, okay? We're going to start off really easy. I want to know, can I multiply? That's all I want to know, okay? We're not going to multiply. I just want to know, can I multiply? So I'm going to give you, let's say that we were multiplying a 2 by 3, okay? Now look, I had this question this morning, so I'm going to point this out. People, is this a matrix?
No.
No, it's just the size of a matrix. It's his dimensions. Do you agree?
Yeah.
Okay, so this morning was like, one of the kids was like, so we're multiplying those two matrices? And I'm like, that's not a matrix. Okay, so that's not a matrix. So now I'm going to multiply it by a 3 by 4. So don't answer it out loud, but I want to know, can I multiply a 2 by 3 by a 3 by 4? Here's what you have to know. What's our favorite kind of drink?
RC.
RC. RC. Rows by columns. So this is rows by columns. Rows by columns. So here's what the rule says. The columns in the first, that's 3, must be equal to the rows in the second. Are they?
Yes.
Yeah.
Oh. Yeah.
3 equals 3. Right? The columns in the first must be equal to the rows in the second. If that's true, then you can multiply them. Yes, we can multiply these. Okay? But wait, that's not all. You've seen those commercials, right? Guess what? This is what you get for an answer. What size matrix?
2 by 4.
A 2 by 4. Okay, you'll get a 2 by 4. Okay, so here's the problem. Now look, when I look at these two things, what does my brain say to look for to see if I can multiply them? The what? The middle two numbers have to be the same. Are y'all thinking that?
Yes.
Yes, or is that just me? The middle two numbers. If the middle two numbers are the same, then what? I can multiply them. Okay, so here's what's going to happen. The middle two numbers won't be the same, and you're going to say no. And when you say no, not possible, then what else do you have to do? You have to tell me why. And so here's what your explanation is going to be. No, because the middle numbers are not the same. No, people. Okay? Because someone just looking at that is going, oh, I didn't know that. When you multiply matrices, the middle numbers on the matrix have to be the same. No, that's not true. Okay? If the answer is no, what is the reason? because the number of columns in the first does not equal the number of rows in the second. Do you understand?
Yes.
Yesterday was easy. If it wasn't possible, they weren't the same size, okay? But now it's not about being the same size. They don't have to be the same size, okay? But the number of columns in the first has to equal the number of rows in the second. All right, you ready for your next one? Here you go. 1 by 2. Can I multiply a 1 by 2 by a 1 by 2? Don't tell me the answer out loud. Just write your answer down. If the answer is yes, then you tell me what size you get when you multiply them. If the answer is no, then you tell me the reason that you can't multiply them. Okay, so what's your answer?
No.
No?
Because the number of columns in the first do not equal the number.
Very good. The number of columns in the first do not equal the number of rows in the second. That's as simplified as I can get it, guys. Okay? I mean, you can't simplify it any more than that. It's just a lot of stuff. All right, anybody got a question? Okay, we're gonna do one more, and then I'll show you a multiplication one. So, can I multiply, not out loud, can I multiply a 6 by 1 by a 1 by 8? If I can, tell me what size. If I can't, tell me my reason. All right, what you say?
Yes.
Yes. And what would I get?
6 by 8.
Very good. These two are the same, so that's why it's a yes. And these two tell you what you will get. He's giving you the rows, because y'all, that's what that represents, rows. And he's giving you the columns, because that's what he represents, columns. So I will get a 6 by 8. Anybody got a question? This is the last. All right, so now let's try one, okay? Now before I do one, I'm gonna warn you, okay, of some things that are happening. Some people will get it right off the bat. And some people, you will still be trying to get it when we do the third problem, all right? So my suggestion to you is to try and see the pattern that we're doing, okay? If you can see the pattern, you'll do better. But if you can't see the pattern, I will give you directions. I will show you how to find the directions, okay? All right, so here we go. We're gonna multiply. My first matrix is 1, -2 for the first row, and the second row is 3, 5. Times my second matrix. My first row is 3, -1, and my second row is 4, 6. Okay, every time they ask me to multiply a matrix, before I even do anything, I'm going to see if I can multiply it and what I'm supposed to get. Okay, so what size is this guy?
2 by 2.
A 2 by 2. Right? 2 rows, 2 columns. Okay? And what size is this guy?
2 by 2.
2 by 2. All right? So can I multiply them?
Yes.
Yes. So what will I get?
2 by 2.
A 2 by 2. Okay? A 2 by 2. So I will get a 2 by 2. Now, do you always get the same size and everything?
No.
No, it just happened to be something weird, okay? I just picked a small one, and not a crazy one. All right, so if I'm supposed to get a 2 by 2, that means he has 2 rows and 2 columns. So I want you to go over here, and I want you to draw blanks for the elements, okay? 2 rows means they'll go, he'll be this way down 2. Do you agree? In this one row and another row. Are you with me? And 2 columns means this is the first column and I need another column. Okay? So now, does he have 2 rows and 2 columns?
Yes.
Okay, so let's put his little brackets around him. Okay? And then we're gonna name each place. Okay? We're gonna name each place. Now listen to me. After, some of you, after 2 of these, you won't have to name the places anymore. You'll be like, oh, I already know how to do that. Okay? But some of you still need to name the places. So we're gonna be in different spots. So I'm gonna be naming the places every time. Okay? So where is this guy? He is in row 1, column 1. Okay? Everybody get that? Row 1, column 1. Where's this guy?
Row 1, column 2.
Okay, row 1, column 2. Where's this guy?
Row 2, column 1.
Row 2, column 1. And where's this guy?
Row 2, column 2.
Okay, now you know what's really cool? First of all, remember, we always go back to this guy. Rows by columns, rows by columns. So listen to me. Your rows will come from the first guy, and your columns will come from the second guy. Okay? Your rows will come from the first guy, and your columns will come from the second guy. So this is the directions on how to get what's here. You multiply row 1 by column 1. Here's row 1 by column 1. My left finger will only go across. It will never go up and down. My right finger will only go up and down. He really only goes down, but he has to go back up to go down again. Okay? Does everybody understand what I'm saying?
Yes.
The rows, these are the rows that I will use. Will I ever use -2, 5 in this guy? No, that's a column, people. You do not use columns in the first one. Rows, columns. RC, colon. RC. Okay? So how do I get this guy? I multiply row 1 by column 1. So I multiply here and here. Here and here. And that goes there. Watch. Now, you do not say this. Don't go and look and go, 1 times 3 is 3, and -2 times 4 is -8. Then your brain's going, what? You just do it, okay? You just do it. What do you get when you multiply?
3
3.
Negative.
minus 8.
Okay, so now before I go on, I'm going to show you the pattern so that I'll catch some of you with this. Some of you will get this. Some of you won't get it, but it's okay. Okay? So here's what you're going to do. I'm going to multiply every row by every column. That's all you do, people. Okay? So my first row times my first column. Boom. First row times my second column. Boom. Then I go to the second row. I multiply by the first column. He goes here, and by the second column, here. Okay? So you're multiplying row 1 times column 1 and then column 2. That's my 2 right there. And then I'm doing row 2 by column 1 and then by column 2. Those are those 2 right there. Okay? So about 20% of you are like, oh, okay, I got it. And the rest of us are like, what?
What's going on?
Yeah, what's going on? So we're going to keep following these directions because that's so cool, y'all. This is not only where he is, this is where he comes from. Okay? He comes from row 1. So put your left finger on row 1. Times column 2. So put your right finger on column 2. Remember, my left finger goes across and my right finger goes down. When you multiply, tell me what you get.
-1 minus 12.
Okay, I get it now.
Okay? This guy. What row am I on?
2.
What column am I on?
1.
Y'all, I'm fixing to do the same thing I did. Look, here's what I did on 1. I did row 1 times column 1, row 1 times column 2. Now I'm fixing to go do the same thing right here. Row 2 by column 1, row 2 by column 2. Okay? So, row 2 times column 1. Tell me what you get when you multiply.
9 plus 20.
Okay, now I'm gonna do this guy, row 2 times column 2, row 2 times column 2. Tell me what you get when you multiply.
Negative 3 plus 30.
Okay, so let's find my answer. What is 3 minus 8? What is negative 1 minus 12?
Negative 13.
What is 9 plus 20?
29.
What is negative 3 plus 30?
27.
All right, anybody got a question? You are okay? So, is what I said true, that it's not really difficult, but it's weird, right? So it's really strange, you've never done anything like that, okay? But it's not that it's hard, it's just kind of strange, and sometimes kids struggle trying to find the pattern. I try to tell you, and y'all are better at finding patterns than people my age. We weren't taught to do math that way, but y'all have been. Y'all have looked for those kind of things all through school. So if you can find the pattern, I'm gonna multiply the first row by every column over here. And then I'll move to the next row and multiply by every column over here. And then if there was another row, I'd do him by every column over here. Okay? All right, Eric.
Are there any word problems for this one?
Word problems? Remind me, I have to go, I should have done it first, but I forgot. I'll go back and show you that in a minute. Okay, I'm gonna let you do one problem while you got it fresh on your mind, okay, and then I'll show you that. Okay, so here we go. Are you ready? So I want you to multiply 3, negative 1, 4, 6 times the matrix 1, negative 2, 3, 5. Okay? You need to do all of that stuff, guys. You need to go, what size are you times what size are you? Can I multiply? What do I get? Draw the lines. If you need the directions underneath them, put the directions underneath them.
Can you sim? No. So what y'all got?
Still working.
Oh, that's what I did.
Oh, man.
Row 1, column 1. Remember, RC colon. These are where my rows come from. These are where my columns come from. Always that way. Okay? So I'm only using rows from the first and only using columns from the second. So row 1 times column 1. So I'm gonna go across and down, and then I'm gonna do the second column, across and down. And then I'm gonna go to the second row, go across and down, the second column, across and down. That's my answers. Okay? So row 1 times column 1. Here we go. 3 and negative 3.
I'll put different numbers in there. I'll put a 4. I'm gonna leave it because I think I'm not right.
Okay. So now I do this guy. He goes here. Row 1, column 2. Row 1, column 2. Negative 6, negative 5. Okay? Now I go to the second row. I'm gonna do the same thing, guys. I'm going here and then here. That's it. Okay? So row 2, column 1. Here. So I get 4 plus 18. Row 2, column 2. Row 2, column 2. Negative 8 and 30. So my answer is 3 minus 3, 0. Negative 6 minus 5, negative 11. 4 and 18, 22. Negative 8 and 30 is also 22. Yes?
Yeah.
Any questions? No questions? Okay, so before I go on to the next one, we're fixing to multiply another one. I meant to do this first and I forgot, I'm sorry. Let me find it. Okay, so remember yesterday, I told you that today I was gonna tell you why we have matrices and stuff? Okay, so, I'm gonna read this to you, all right? It's about a company. We have a company, all right? And our company manufactures small and large steel DVD racks. So small and large metal racks that you can store your DVDs on, okay? They have a wooden base, and each size of rack is available in 3 types of wood. You can get a walnut one, a pine one, or a cherry one. The sales for the racks for last month and this month are, last month we sold small walnut ones, 125 of them. We sold small pine ones last month, 278. We sold small cherry bases and racks at 225. This month we sold small walnut ones for 90. We sold 95 of them. And we sold small pine ones, 316, and we sold 205 small cherry ones. Last month, the large walnuts, we sold 100. The large pine, we sold 251. The large cherry, we sold 270. This month, the large walnut, we sold 114, and the large pine was 215. And the large cherry was 300. So that's a lot of information. Do you agree?
Yeah.
Okay, so watch this. Watch what I can do with a matrix. I can take that information that I gave you as a paragraph, and I can lay it all out as a matrix. Okay? And watch how easy it is to read. Instead of you going back through the paragraph and trying to search out things, read this matrix and tell me, this month, how many large pine DVD holders did we sell?
215.
Everybody got it? There it is right there. This month, large pine, 215. Last month, how many small walnuts did we sell?
125.
Does everybody understand? Do you see how much easier that is to read? Do you see all that? Okay, now let me ask you this. What if we were in a business meeting, okay, and your boss came in and said, oh my gosh, we got a problem. Okay, we got a problem. We got to cut some cost, people. If we don't cut cost in this business, we're going to have to cut people in this business. Okay? So, can you look at that and tell me who should be cut? Who should we not make anymore and save some money? Why?
Because he's selling it.
Yeah, wait, he's not selling as good as anybody is. Do you see how easy that was to look at it and tell that? Could you do that if all that
Wait, are
information?
those how many were sold?
Yes. Could you do that if all that information was in a paragraph? You could, but might it take longer? Yes. Okay? So, here's what I'm gonna tell you. Without these labels, if I give you this matrix right here, do you know what in the world I'm talking about?
No.
Okay, so the first thing you should know is that if you have a matrix and it has no labels, it's worth nothing. Okay? You have to label your matrix. Now, let me ask you another question. Could somebody else have written, this is a 3x2, do you agree? Could someone else have written these matrices as a 2x3?
Yeah.
Yeah, they could have said, I want my small and large to be my rows, and I want my columns to be walnut, pine, and cherry. Do you understand? So, it doesn't matter, that's not gonna affect the information, it's gonna affect the way it looks, but it's not gonna affect the information. I can still find it and everything. Okay, so on the worksheet that you either have or I'm giving you today, okay, there's a problem at the bottom of the worksheet, and it gives you a bunch of information, and then it says, write a matrix. What does the word a mean? One. So if you put that information in two matrices, you're wrong.
Is that two matrices right there?
That's two matrices, but they represent two different things.
Okay.
Okay, this is last month and this is this month, okay? So, they're asking you to put it all in one matrix, okay? Now, if you write that matrix and you don't label it, is it good?
No.
Y'all, it's not any good, it doesn't tell me anything. I don't know what you're talking about, okay? So make sure you label your matrix and make sure that if it asks you to write one matrix, you only write one.